a lot of the times we can't find a greatest common factor among all of the terms in the expression. So if you have 3, 4, 5 terms and you're trying to find a greatest common factor or a factor that can divide all of those, usually that's not the case. But there are situations where maybe you can factor you can find a common factor between a set of terms. So we're going to look at this process, and this is known as factor by grouping. So if we see in this example, we have 4 terms. There isn't anything that can evenly divide all of these. So what do I mean by that? Well, let's see. Here we have the number 4, the number 3, and the number 12, and in here we have the number 1. There isn't anything that can divide all of these except for the number 1 without causing any remainder. So for example, here we have 3. Okay, 3 can divide itself, but 3 is a prime number. So 3 won't be able to divide 4. So that's not a common factor. 3 can't divide 1 either. That's going to result in a fraction of a third. So there's no common factor. Another way to see there's no common factor is to look at the algebraic, the variable. There's x cubed, x squared, x, but there's no x here. So maybe I could say, oh, I could divide everything by x, but not really, because since there's no x with the 12, there's you're going to have a remainder. So since there is no common factor, the greatest common factor, let's group this into pairs and see, okay, what if I can find a common factor between the pairs? So that's what I'm doing in this step. So there is a common factor in this pair, and there is a common factor in this pair. The common factor in the light blue pair is x squared. The common factor in the purple one is 3. Both of those can be evenly divided by 3. So now, when I factored out my common factor among these two terms, well, x cubed divided by x squared will give me this x. 4x squared divided by x squared would give me this 4. Now let's do the same thing with this pair. 3x divided by 3 gives me x. 12 divided by 3 gives me 4. And then I see this and this are the same. So I can group these together here. And then that just leaves me with this x squared and this 3. So now I am in fully factored form. So let's use that process here. So again, there is no common factor that can divide this, any of these terms. But let's see if we can find a common factor between the pairs. So this is one pair, and then this is the other pair. Actually, I don't want to put parentheses because that's confusing. This is pair 1, this is pair 2. Okay, among pair 1, well, there's no coefficient. There's a coefficient of 1. So this pair won't have a numerical factor. It will only have an algebraic factor in relation to a variable. So we know that, okay, we choose the lowest power as our variable to divide x cubed and x squared. Now let's look at the other pair. Okay, both of the terms, only one of the terms has dx, the other one doesn't. So in this case, our common factor can't have the variable. But let's look at the numerics. We have a -2 and a -10. Well, both of them can be divided by -2. Because -2 divided by -2 is 1. -2 divided by 10 will give you 5. Okay, so now I'm going to write this as x squared. And then here I'm going to write the -2. So what's happening? I'm taking this x cubed and dividing it by x squared to get x. Here, I'm going to do 5x squared divided by x squared. That leaves me with 5. Here, I have negative 2x divided by negative 2. That leaves me with my x. Here, I'm going to have negative 10 divided by negative 2. Leaves me with 5. These are the same. So now let's group them together. And then what's left over, group those together. And we're done.